This screen is a review of all of the equations and ideas that we've talked about previously with regard to pH calculations. You can see we have several equations there at the top of the screen. At the bottom of the screen, we've stated again the significant figures rule for logarithms, which is that the number of significant figures in the number must be equal to the number of decimal places that you express in the logarithm. On this screen there are two constants. They're right here in the middle of the screen. You can see this number 14.00, and then in the equation above it on the right 1.0 times 10 to the negative 14th. Those two constants are valid only at 25 degrees Celsius. Those would change if the temperature changed. However, we're always going to assume that we're at 25 degrees Celsius unless we're told otherwise. We also discussed in a previous lesson this pH island diagram. On this diagram you see all of the equations that were shown on the previous slide. And the way you use the diagram is simply you start at the island where you know the quantity, and then you work your way to get to the quantity you're asked to calculate. And the arrows show you which equations are valid for moving in which direction. If the hydroxide ion concentration is 5.6 times 10 to the negative 11th molar, find the pH. If we look at our island diagram, we're starting at the hydroxide ion concentration, which is in the lower right, and we're asked to find the pH, which is in the upper left. How do we get from the lower right to the upper left? We can either go up and over, or we can go over and then up. I'm going to go both of those ways for you so you can see that you get the same answer no matter which way you go. If we go up and over, that means we need to calculate first the hydrogen ion concentration using the idea that the product of the hydrogen ion and hydroxide ion concentrations is equal to 1 times 10 to the negative 14th. I'm not going to show you that work. I trust that you could find that using your calculator, that the value of this island in the upper right is 1.79 times 10 to the negative 4th molar. I've added an extra significant figure in there because I don't want to round too early. Now we're going to scoot from the upper right to the upper left using this equation. The pH is equal to the negative log of the hydrogen ion concentration. In other words, we need to take the negative logarithm of this number, 1.79 times 10 to the negative 4th. And when we do that, again I'm not showing my work, we get 3.75 for the pH. Suppose instead we had chosen to go over first and then up. Well, if we go over, we would need to find the pOH, and we would do that using this equation that I'm circling with my laser pointer in the middle of the screen and a little bit to the right to take the negative log of the OH concentration. Now, if you look in the upper left corner of the screen, we're given the OH concentration. It's 5.6 times 10 to the negative 11th molar. So if I take the negative logarithm of that, I get this number here, 10.25. In other words, the value of this lower left island is 10.25, and then I just need to go up to find the pH, and we know that the sum of the pH and the pOH must add to be 14. So what plus 10.25 equals 14? Well, 3.75. So you can see that as long as you use the equations correctly, it doesn't really matter which way you go around the island diagram. You can get the same answer by going two different ways.